Hey friends, welcome back to the channel. So it hasn't been a while. I just put out a video a few days ago and I am very proud of myself for going ahead and starting this next video also. I hope you guys are proud of me too. Anyway, so this week we are going to be taking a look at, just very briefly, the existing Rust engine setup. Since I haven't done anything with that on video yet, I'm just going to have a very brief overview of how that's currently configured. And then we're also going to take a very brief look of what I have so far with rendering, which is essentially just structs for vertex arrays, index buffers, vertex buffers, and shaders. That's pretty much it. And I'm drawing a triangle currently. All of this is like fucking day one rendering, and that's fine. Like I have done very little setup up to this point intentionally because I want to work through this whole process with you guys. With that said, I do have a plan. The plan is we're going to start with a very, very simple 2D rendering setup. Now, Alkahest, the game, is going to be a 3D game, but we do still need 2D rendering for things like the UI and stuff, and it'll be really helpful in development to have like text output and things like that for debugging or for performance stats and metrics, things like that inside of the game window. So the first task is essentially going to be creating a UI renderer. And that's basically going to have like drawing a quad, drawing a textured quad, rendering fonts, and that's pretty much it. And all of that like with positional shit on the screen. That's pretty much the plan for the 2D renderer. Eventually, I will probably implement something where all of those pieces are going to like a separate frame buffer that's then overlaid on top of the primary buffer right before being rendered to the screen to make sure that the UI is always on top of everything else that's being rendered, because that's important. And I'm also probably going to implement things like batching and stuff like that at some point in the future for the UI renderer. But my goal right now is to just build up some momentum in rendering and then very quickly move into 3D rendering, because that's where a lot of the effort for rendering is going to be. You may remember I did set up rendering in the initial version of the C++ engine, so I'm not going into this completely green. I would not call myself a graphics programmer at this point. Hopefully, at some point along the line of this engine development process, I will feel comfortable calling myself a graphics programmer, but we'll see how that goes. Anyway, yeah, so let's just go ahead and get started real quick. See, this is like a live stream-ish style. I've even got little transitions in the... Yeah, that's fun. Anyway, all right, so let's just get everything pulled up here. So here in the source folder, this is basically like the sandbox app. So all I'm doing is creating a sandbox. The way that the engine is set up for Rust, so there are some differences between the Rust engine and the C++ engine, and just in terms of how some things are done. There's very little like global state or anything like that inside of the Rust engine, as opposed to the C++ engine. Like everything was global, or at least in it was private in terms of like it was private to the engine code, but it was still like it was all global. And so things are different with Rust. And the most significant one, at least in the beginning, was changing how the project starts up. So in the C++ version of the engine, there were some external functions that were declared but not defined, which were init, update, and cleanup, and those were on the main game class, and then you had to implement those functions on the game side. Here, instead, there is an application trait that has the init, update, and cleanup functions that need to be implemented. So you implement those, you create an instance of that game, or of the application trait. So in this case, an instance of sandbox here. And then you pass a reference to sandbox into the Alkahest run function. And that's kind of our main set up here. And then I also have like a little util folder that is setting up like the basic concept of a project folder that eventually will be built out such that my goal is that the sandbox app here is eventually going to become like the game engine editor. And then that can be used to build actual games. Is the plan. So we'll see how that actually holds up in the future. Okay, and then we've got the Alkahest folder, which is like the engine library itself. Eventually, my goal is to set up the Alkahest library as a crate that anyone can like pull down into their Rust project and can start building games with. Obviously, it's not at that point yet. Once it is, that's the plan. So here in the lib folder, because this is a library, not an app. Oh, I don't have any docs there. But yeah, just some documentation. Here's the application trait that is implemented on the app side, and then we're taking an application reference, a mutable reference here, and then we just this is just some error or some console logging macros that I created that will take, you can either just pass a string literal, or you can pass a format string and then some extra arguments, and it will compose them just like the print line and the print macros in Rust. And it actually uses those, I believe. I can double check that later. But yeah, so then we have a game, like a sysinit function. Sysinit, sysupdate, and syscleanup were all also a thing in the C++ engine, but they're kind of different here in that it's like game versus application, so technically they're separate, and like the run function is calling all these things, as opposed to like doing some weird inheritance stuff to make sure everything is called properly. But anyway, so the sysinit function returns an engine context. This holds all of the global state, of which there is currently little. And then we call the app init function in case the app is relying on anything in the engine context. Then we call the game sysupdate, and we pass it the... Right now it's just passing the window context. That should probably pass the entire engine context at some point. Anyway, then this is like I've kind of just BS to this in currently. This is just calling the draw function on the render context, which is nonsense. It's literally a function that creates a triangle, draws the triangle. This is not what the render is going to be. This is just how I kind of like bootstrapped it last week. And then we call the app update function, and then before exiting, we clean up the engine context. We call the app cleanup function so it can clean up all of its stuff. Boom. Golden. Yeah, so inside of the game here, this just sets up the sysinit, sysupdate, and syscleanup functions, and these all kind of do nothing other than we set up the async cleanup here. This probably should be moved into like a context cleanup so that all of the engine context is cleaned up and I don't have to manually do all of it. Or at least don't have to do it here. I'll do it in the context cleanup function. But anyway, then sysupdate just handles right now processing the events and swapping the buffers for the window context. Up here, we're calling the context init. The util function, the util folder is kind of a mess currently. It's got a lot of stuff, but one of the things that it has is context. So we currently have the engine configuration, the window, the async, which is like a job system type deal, and the render context, and holy crap is that bugging me. We'll commit that later. Anyway, but yeah, so render context is probably not going to be there. This is, like I said, just bootstrapped for making a triangle. We also have some, I have moved over 2 containers, the handle map and the ring buffer from the other engine. We have an input system that has like basically a per platform input implementation. We also have a per platform window implementation here. This may or may not change. I essentially at this point am leaning toward only implementing OpenGL on everything for now, render-wise, because OpenGL is cross-platform, and then eventually later converting all of the OpenGL to only Vulkan, which would mean that I wouldn't need different things per platform because everything is going to be either OpenGL or Vulkan, at which point there's like everything's getting the same code. There wouldn't be any actual difference. I'm not sure on that one though. Right now, OpenGL is the way to go because it's the simplest to implement. That is also cross-platform. I can't speak to the implementability of DirectX, honestly. Anyway, yeah. So we got some resources that are handling resource management. Those just kind of have like an asset manager with some functions. This is a trait, and then you also define an asset that trait manages. So like our configuration manager has a config context is what it manages. It caches stuff. It's got all kinds of stuff going. Same for the shader manager. Ignore these warnings. It's just that there's no documentation, I think. Okay, so that is pretty much it. The only thing we haven't looked at is render. Render, we currently have index buffers, shader programs, vertex arrays, and vertex buffers. All of these are pretty much exactly what they were in the C++ version of the engine. They are just rustified. And by that, I just mean that things, like I've cleaned up some of the memory usage, like the everything is in the Rust style, and that most things are immutable by default, and so everything has been moved over and oxidized and all that. And then here in the main module file, we're just defining this monstrous init for the render context that literally is just creating a single vertex array with a triangle, and that's pretty much it. So, with that said, if I run cargo run here, boom, we have a pretty colorful triangle. Yay! And actually, you guys can see we have events, or input events. I can click, scroll, I can type. Yep. So yeah, that is pretty cool. And then when I exit, you can see we called syscleanup and sandbox cleanup. Great. And yeah, that is pretty much the current, that's pretty much the current state of the engine. So, real quick, while I was gone, I just moved the buffers and arrays and things inside of a primitives folder just to clean this up a little bit. And so this primitives file actually just like privately declares these and then publicly uses their contents. The purpose of that being so that I can just import primitives slash vertex, whatever, vertex array, vertex buffer, etc. But yeah, that was really just to clean up that file. Oops, let's do that one. Oh, come on, yeah. All right, and so the plan is, instead of having the render context here, what we're going to do instead is we're going to create a new file that's going to be, we're going to call that renderer 2d.rs. I think that's that'll be a valid module. Because then here I can do mod renderer 2d. I'll do add a thing here. So, oops. And now that actually says that it's there. Okay, cool. In that case, we essentially need to decide at this point what our renderer 2D is going to look like. And so we've got a couple of options. So what I'm thinking at the moment is that we're going to swap to full cam here. Okay, so my thought right now is, first of all, we've got our separated renderer 2D from our regular renderer. The renderer 2D is going to be very minimal and essentially is just going to be a UI renderer. And what I'm thinking is so we kind of have this separation between our renderer, like the actual rendering nitty-gritty details, like the renderer, versus the interface that we use to interact with it. So I think, oops, I keep knocking my microphone around. So I think my current plan, and this may change, but my current plan is going to be to set up the renderer 2D as the nitty-gritty details of running. So this is probably going to be running off of a single shader, maybe two shaders, one for font rendering, one for everything else. But this renderer is going to keep track of that shader. It's going to handle like binding vertex arrays and starting shader programs and sending draw calls to some eventual like render queue that is then probably on a separate thread executed by the graphics card. And then we have the UI renderer, which we're going to tell the UI renderer, draw a box at this position with these coordinates, and the UI renderer is going to pass that onto the renderer 2D via that like low-level API of like draw textured quad or draw something whatever. Those individual methods will probably depend on those individual methods will probably depend on which shader is being used. So the 3D renderer will almost certainly be a little more robust in that you'll probably on the low level side pass like a VAO and a shader into the draw call, as opposed to the 2D renderer is going to have maybe 3 shaders total. That's assuming that I have separate shaders for colored rectangles versus textured rectangles, and I may or I may not. But yeah, so all right, let's just start writing. See, there's a flaw in what I currently. Holy shit! I've been recording this whole time and have not had. That's hilarious. Okay, friends. So I am back, and funny story, technical difficulties, all that. Main problem with this stream of consciousness, like just trying to record a single thing and do the thing, is that I swapped to the full cam and I forgot to swap back. So. Sorry. I have only done 2 things so far, which is I moved all of my primitives into a primitives folder to kind of clean the render folder up a little bit. And now I've created a renderer 2D file. Right now I have only implemented a single function, which is draw quad, in which you pass a vertex array and a shader program into this function, and it just renders the thing. So I also have this other issue, which is if I were to just create a draw function, I've just realized this. If I was just to create a draw function, say we have the same vertex array, same shader, And I want to activate the shader. I want to bind the VAO. I want to draw elements because I don't know how many elements are, or I don't know what I'm drawing. I don't know that it's a quad, so we're just going to do a basic GL triangles. What's our count here is the problem. So this issue, essentially, the issue here is that I don't have a way to keep track of the count of elements currently. So I think what I'm going to do instead, before I do anything, I'm just going to close that so I've got a little bit more breathing room. We're going to open up the vertex array, and then we're also going to say index count. And that is going to also be AU32. Index array here. That's going to be, I'm sorry, ID index count is 0. It needs to be vertex count. That's a better name. Oops. Vertex count here. Link attributes is fine. So essentially, I've got this VAO, VBO, and what I think I'm gonna do, number of components, stride, offset. What is? I gotta double check my code here. Components is how many pieces there are. That's the stride. Type. That's okay. Yeah. Okay, that doesn't give me the information that I need. However, comma, what I can do is go into our vertex buffer. This is going to have, it's got phantom data. We're going to add another vertex count. Of, hold on, because I'm doing the VBOs here. I don't need the count on vertices, I need the count on indices. So it's not a vertex, it is an index count. All right, let's go back up here. Let's just do that real quick. It's an index count. So then we just need to make a function set index count, the mutable self, and a count, which is going to be a U32. Actually, I guess it's a U size, really. But that's all right. And we're going to say self.index count equals count. And then down here, we bind the EBO. We're going to say VAO.set index count is going to be, oops, oh, I accidentally hit U. Huh. VAO.set index count to be indices dot length as U32. Cannot borrow view is not as declared as mutable. Okay. That mutable VAO, and then value is moved there. There we go. So there's going to be a better order of operations here, ultimately, I think. But anyway, so that lets me set the VAO index count. Actually, I don't even need to have a method for that if I let that be. Since that's already mutable, like, just let it be accessed here. VAO dot, oops, hello, dot index count equals indices dot length as U32. There we go. Cool, 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 cool. Oh, excuse me. All right, and then here I replace this as VAO dot, sorry, self dot VAO dot index count. Found as I32. Why does it want a signed integer there, by the way? Like, can I render negative indices? Like, I don't get it. Or is it like and so the alternative is that it's limiting the, it could just be like an arbitrary decision. I doubt that there's any real logic to that. Okay, so then here we do VAO dot index count as I32. Our type is GL full GL unsigned int, because here we're doing indices. And then 0, right, 0 as const unused. And then I need to unbind. And then I guess also shader dot deactivate. I'm not entirely sure that that one's necessary. I didn't do it here, but yeah, probably. Whoa, hello. There we go. Let's just make sure, oops, that this runs properly. It does. Great. Cool. So then here, whoop, hello. So then here, instead of doing this, we're gonna say use renderer 2D, there we go. And then down here, so I've already handled binding all of that shit and doing what it's supposed to do. So that here, we're gonna say renderer 2D dot draw unsafe function draw. Yeah, that should be there. Dot draw, and we're going to pass self.vao and self.shader program. Oh, I'm sorry, self dot. Did I really just call that S? Right? Renderer 2D. I'm sorry, it's supposed to be that. Boom. Because it's stateless. Yay! So now, if I do that, let's do this again. Renderer 2D drop. Boom! Okay. So that has successfully pulled that out of this class. And essentially what we could do is have the, have the renderer 2D here's what I want to do. This is gonna be the last thing that we do here, which is to say that we're going to make a pub crate here. Use. We're also going to add that here. Oops. Okay. And here. Actually, I need all of these, I guess. Just for now. I wish I could. There we go. And apparently I don't have trace actually implemented anywhere. I mean, I guess it doesn't really matter. Okay, so right now we're just going to leave this. What I eventually want to do, I think, is remove this render context. I'm not even sure that the render context needs to exist. I just kind of threw it in here because, you know, needed some stuff to work. Let's not delete that just yet. Yeah, we'll just leave that for now. And then everything should still be working. It is. Great. Okay. Let's finish this up. So yeah, I've got the renderer 2D here. I will probably, like I said, be moving the draw quad to another... Or I'm sorry, removing the shader program here. So instead of having that shader program, I'm probably going to have like a draw. It's more likely that I will have a pub unsafe function draw textured quad with a VAO that is a vertex array reference. And then a pub unsafe function draw draw, just like the basic quad is going to be a colored quad, and that color data I think will be stored inside of the VAO, and then a draw text that is also going to take a vertex array here. I'll need to double check how I was doing text drawing. How I was drawing text in the old version of the engine, because I remember I kind of struggled with that, so a lot of that is probably going to be kind of ported over directly. But yeah, so here's what we're going to do. We're going to say we're cool, we're done on this video. And we have a couple of tasks that we're basically set up for next time, which is that we are going to set up the different shaders for drawing an untextured quad, a textured quad, drawing text, those things. Once those are set up, we'll be able to set up these individual these individual functions. And I need to look into how draw text should work based on how I had set it up previously. But yeah, so for right now, we've got a plan going for our renderer 2D. Hopefully next time we're going to be able to implement the different draw functions that we need, i.e. quad, textured quad, text. There may be more to that eventually, but not currently. And yeah, that is going to be our plan for next time. That's all I got for this time, and I will see you guys later. Bye!